Use the graph to complete the following. So I need to look at this graph and decide which of these functions could represent it. So I see there's an 80 here, and I see the pattern of it is going down like that, as opposed to some problems where they go up. So there's a couple things to think about. Well, what do these mean? I know that 80 is my initial value. It's the value at time 0 or at x equals 0. And I know the pattern going down is decay, which means my growth factor needs to be between 0 and 1. And actually not equal, just less than, just between. So which one has that? Let's see, so my initial value, this has an initial value of 80, this has an initial value of 80, this one, that one, that one, that one, and that one. So now the question of which ones are decay. So let's look at the key factor, the growth or decay factor, and see which one gives us what we need, because it could be more than one. So you can see 5/2. Well, that is a fraction, but a fraction isn't what decides it. It's a number between 0 and 1. 5/2 is 2.5. 2.5 is not less than 1, so this is not decay. This would be a growth function starting at 80 and would look going up like that. So not that one. 2, again, same idea. Doubling, not decay, not between 0 and 1, so that's out. 1.6, for the same reason, out. Now, 80 minus 2t. This is not even exponential growth. This is a line. Right? It would be a line that goes straight down through 80 with a slope of -2. So linears are not exponentials, so that's definitely out. 80, 1/2 to the t. That seems fine, right? That's a number between 0 and 1. 80, what is that, 1/4? 1/4, that looks good. 80 to the 0.3. 0.3 is between 0 and 1. That looks good. So those three are fine. Those represent. This function could be any of those. And without any more information, that's all. That's as specific as we can get. So we just described any similarities you notice about the functions. That could not represent the graph and that could. Explain the chocolate scenario. Okay, so I'm shrinking, right? So and I'm starting with 80. So this is start with 80 and eat. You know, maybe it's 1/2 or 1/4 or the 0.3 is an interesting one. And the quarter is an interesting one too, because if you think about the quarter one, let's think about that. So I start with 80 and then I'm multiplying by a quarter each time, so it'd be 20 and then 5. So I'm not actually eating to go from here to here. I'm not eating a quarter. I'm keeping a quarter. So I'm actually eating 3/4. So, and eat, for the first scenario it's 1/2. For the second it's eating 3/4. For the third one, where it's 80.3 to the t, I'm keeping 0.3. I'm keeping 30%, which means I'm going to eat 70% of what I have left. So this is one of the hard ideas, is that you have your initial value times the amount you keep raised to the time is equal to the amount at time t. Okay, the amount you keep, not the amount you eat, not the amount you take away, not the amount you lose, not the amount you gain, the amount you keep after the next time. So if it's growing at 10%, you would keep 100% plus another 10%, 1.1. Okay, so this is going to be one of the key confusing ideas that a lot of students get mixed up on, is that it's the amount you keep is what you put in there, not the amount that you take take away or that you add.